So I'm here to tell you about some exciting innovations in data and intelligence. Our world is rapidly undergoing an enormous digital transformation. Everything is digital data. What we observe, what we record, and how we act. Everything is being digitized. And everything becomes a data analysis problem. Understanding the world around us, understanding the world inside us, and understanding how we can make this world a better place for each and every one of us. So whether it's unraveling the mysteries of the universe, or curing cancer, or making the world a more sustainable place for us to live in, the answers to those problems lie hidden in vast amounts of data that we are now able to collect. And it's the same in business and government. With platforms and tools to explore that information that is latent in the data, we stand to make enormous progress. And today, there is an enormous convergence happening. There is a convergence of cloud, data, and artificial intelligence that is coming together. And that's revolutionizing how we transform that data that we collect into insights and intelligent action that change our world. With the limitless computing power of the cloud, the Internet of Things, and the new capabilities like machine learning and AI, organizations can now build and deploy intelligent applications that change their business and change their operations. These technologies have the power to disrupt almost every industry. Entire systems of production, management, and governance are being transformed. Let me give you an example. Consider Cochrane. It's a global independent network of researchers, professionals, patients, and caregivers working to transform healthcare with data analysis. So now let's hear from them and see the video.
Systematic reviews summarize all the best available research evidence to inform decision makings in health. Research had been done that looked at whether steroids were helpful in improving the maturation of premature babies' lungs. The reviews showed conclusively that giving steroids saved lives amongst premature babies, and that has probably saved many thousands of lives.
And for a typical review, we might well have 20,000 citations to sift through as a team.
It can take 2-3 years to complete. Project Transform is an artificial intelligence project that brings together the technology that's able to manipulate and analyze data very efficiently.
We've been able to create a data set that can train the machine to help us do this task so that we can then better direct human effort where it's most needed.
We're using Cortana intelligence to enable us to develop and deploy these machine learning applications in the cloud. We've got a series of different classifiers where we narrow the scope of what a particular citation is looking at. What we're able to do is to be able to identify the research which is likely to be relevant for a particular review. I'm using Azure Machine Learning Studio to develop and deploy web services which make these classifiers available. We're then able to visualize the performance of the classifier across the set of studies. We find most of the relevant citations much earlier in the process.
What I love about all of this is that it's all about that partnership between the human and the machine.
Artificial intelligence will allow us to answer more complex questions more efficiently and with more precision, improving decision making and therefore helping patient health.
Microsoft's data platform is built for the needs of such leading customers in every industry. Now, we learn from them 3 important themes for data platform innovation: intelligent, trusted, flexible. First, intelligent. We learned that it's critical to bring intelligence to where the data lives and is generated, in databases and applications. And that's incredibly important to customers because customers find it increasingly hard to move vast volumes of data and manage secure, compliant, data-driven applications. Second, trusted. We have learned that it's critical for data platforms to provide state-of-the-art features for managing security and compliance. Data is the most strategic, most high-value asset for our customers, and they want it safe. Third, flexible. We have learned that our customers work in extremely heterogeneous environments. They heavily leverage open source innovation, and they need flexibility when it comes to the choice of the platform, programming languages, and data infrastructure. So these are the three themes: intelligent, trusted, flexible, that are the foundation of our data strategy. In the rest of my talk, I will share some of the key innovations we are making along these dimensions. Let's now talk about the first theme, building the intelligent data platform. And this is very exciting. Microsoft has been investing heavily in machine learning and AI for over 2 decades. We have over $12 billion in R&D every year. We can bring all of these innovations into our data platforms to enable you to build the next generation of applications. And we want to make it today very easy to deploy advanced analytics and intelligence in these applications by integrating that into the data platforms. So let me talk a little bit more about it, about bringing intelligence to where the data lives in these data platforms. Why do that? Here's the motivation. In the past, a common application pattern was to build and host statistical and analytical models and business rules associated with them outside the database in an application layer specifically built for that. Well, this meant that the application layer had to perform a tremendous amount of heavy lifting. Fast data extraction, concurrency, high availability, resource management, security, access control, compliance, manageability, the list goes on. It is a lot of heavy lifting that you have to build independently of the database layer. But guess what? A modern database platform already gives you all of that. It already does that heavy lifting. And now we are exploiting that capability already built into these to make it trivially easy to host machine learning applications. So you can have AI in a performant, multi-threaded, distributed way at scale executed directly in the database. This includes Microsoft machine learning algorithms and the leading AI research that is coming out of Microsoft Research, and even open source R and Python. All of this can run in the database now, leveraging the power of the database management system. And this is available to you both on-premises and in the cloud. Yeah, that's right. No one but Microsoft can do this for their customers. Let's talk more about how we are bringing intelligence to your databases. Earlier today, we announced the Community Technology Preview 2, CTP2, of SQL Server 2017, formerly known as SQL Server vNext. It's very exciting. This is the most secure data platform with built-in intelligence for all your data. It's on Windows and Linux, including Docker. It provides unmatched TCO with everything from BI reporting and now AI built in. There are 4 things in particular that I'm excited about sharing today. First one, graph processing. Graph processing is important for fraud detection, social network analysis, and modeling IoT networks. That's where a lot of modern data is being generated in cutting-edge applications. So the next version of SQL Server will support graph objects and graph queries to efficiently model and analyze such data. That opens up a whole new set of possible applications that you can efficiently build on the SQL Server data platform. Second, adaptive query processing. It learns from prior query executions and optimizes for the best performance. So now you have a learning database that tunes itself to be even more performant as it is used more and more. Third, we have made some incredible strides in extensibility in SQL Server. And I should spend some time on it. It's very exciting. It now supports executing of Python And a query, a SQL query, can even mix R and Python code. And this is incredible extensibility. You can install your own Python packages and run arbitrary analytical computations close to the data in the database. And then 4, using all of that extensibility, we have made some incredible advances in incorporating AI into SQL Server. We have added in some of Microsoft's most advanced ML algorithms into SQL Server with GPU support. This is super exciting. SQL Server is the first commercial relational database management system with deep learning. And now you can use the latest deep learning frameworks like Cognitive Toolkit and TensorFlow to run deep learning models against data that live in the SQL Server database. You can deploy these models without data extraction out of the database and get incredible simplicity when building highly available, secure, compliant, and high-performance AI applications. The best way to understand all this power is really to see it in action. So now let me invite Rohan Kumar, the GM of the Database Systems Group, to show you an exciting demo of this new capability. Rohan?
Thank you. All right. So thank you, Joseph, and hello, everyone. I'm extremely excited to show you the first commercial database with built-in support for AI. More specifically, I'm going to show you how to build and deploy Python applications in SQL Server. And not just any Python application. I'm going to show you GPU-powered deep learning application running in SQL Server that actually does classification of medical image data that is stored inside SQL Server as well. Deep learning and AI are changing lives. Cancer is one of the leading causes of death here in the United States, and the costs are in billions of dollars. Early and accurate detection is key in improving patient outcome and reducing these healthcare costs. Increasing the accuracy and detecting it early can be done by augmenting medical judgment, medical decision making, by using deep learning technology for doing medical classification, image classification. Now let's get going with the demo. All right, so what you see on the screen is a web application that you find in a radiologist's office. So I'm logged in as Dr. John T. And every morning I come in and check the reports of some of my patients. I'm particularly interested in looking out for my patient, Anna. So I type in a name in the application and I see basically a bunch of statistics around her medical history. What you see on the right-hand side of the screen is basically the CT scan images, active images of her lungs. Now, based on the analysis of the scan, the application is going to determine the probability of Anna getting lung cancer. So let's go click on the Analyze Scan button to see what the result comes back. What's happening in the background when I click the Analyze Scan button is basically the deep learning model is actually working against all the CT scan images of the lungs images of Anna to figure out the probability of her having lung cancer. And here's where you see the prediction came back with a 55.48% probability of her, which is pretty high. Now, what does it take to build a deep learning system? Let's take a look at that, which is behind an application of this kind. What you see on the slide here are the two main steps in building a deep learning system. The first step is what's called the learning phase, where we take the images, the raw images of the CT scan, and pass them through a process called featureization, which results in a bunch of numerical values for certain features that are used for classification. Those numeric values of features, along with some label data that was manually created, is used to train the model, the classify model. In the scoring phase, the patient's images are taken, and they again pass through a featureization process, and based on the feature values, they're actually scored against the model that we trained in the first step to determine the probability of the patient getting lung cancer. Now, how do you build an application of this kind? It's actually a fairly complex process to build intelligent application. The three main challenges. The first one is to build the intelligence inside the application. The web developer, in this case, had to work with the data scientist, which both of them use different tools, different languages to coordinate, and even happen to be in different organizations. That's very complex. The other challenge is to essentially move the data from the data platform it's stored on to the intelligent application, which effectively means everything around compliance and all could be at risk. Security, governance, etc., which was there in the data platform. And even if the first two challenges are actually met, there is the third challenge of actually migrating the high volume of data, which is very, very hard to do. So typically, the data scientists take a very small sample of the data, which again lands up impacting the accuracy of the model. But for the application that we built, we didn't have to face any of these three challenges because we built it on SQL Server. All the data, the intelligence, and the models that you saw that go into building the deep learning system are integrated deep inside of SQL Server. It's all built in. All that the application had to do, the web application in this case, is issue a store procedure call that essentially came back with a result, which is the probability of the patient having lung cancer. That is it. It really sort of came down to just a single store procedure call that the application had to make. All the intelligence, all the data, all the models that we created to back up this application were all built into SQL Server. All right, now let's go take a look at the code itself. All right, so basically what you see on screen is Visual Studio Code hosting the application code. And the thing I want to highlight is there's a lot of code that basically is just around the UX of the application, etc. But the intelligence of the application is just a single line, which essentially invokes a store procedure inside SQL Server. That's it. In fact, as an application developer, I didn't have to worry about understanding how all that intelligence is getting built. All that is taken care of me by somebody who already built the deep learning model and operationalizes within SQL Server. That's how easy it is. Now let's take a look at what's happening, the magic that's happening in the back end. For those of you who are familiar with our services in SQL Server, what you're seeing in the Management Studio must be very familiar. Effectively, we have SP execute external script, which is how you sort of define store procedures that execute our code with SQL Server 2016, now have support for the Python language. Everything else remains the same in terms of the parameters, the extensibility, the trusted extensibility model that we added to support R now essentially supports Python as well. Very, very simple. Now let's go back and sort of take a look at the actual T-SQL code with Python built in that was used to generate the features. Remember, feature extraction is the very first step that we go through. So let me sort of bring up the store procedure over here. Again, what you see on the screen is basically a few lines of code that do a lot of deep learning magic, right? The first one, the thing that I'm sort of getting is essentially a model that has already been operationalized, already been trained and hosted in CNTK, which is an open source library from Microsoft for deep learning that I'm sort of using to install inside SQL Server. So the first step is to get all the scans from the patient images. Again, pretty straightforward. The second step essentially is to manipulate these images. These images are actually pretty large in size, but you don't need all that data. So there is OpenCV is an open source Python library that can be used to sort of reduce the size of the images while maintaining all the value. So again, another point to call out essentially is it's so simple to basically host all the open source Python libraries right inside SQL Server. We just did that in the manipulated images using OpenCV. The next step essentially is the feature extraction. Now, it seems there's a single line, but here's where there's a lot of magic of CNTK running on GPU on the local machine, right? So this is about 1,500 patients worth of data is what we have back in the application, and that comes to around 250 or 300,000 images. Going through the entire feature extraction phase takes about 53 minutes because the code essentially is using the amazing amount of parallel processing power inside the GPU. Just for comparison, if the same thing was done without using GPUs, it would have taken 30 hours. That's 30x longer. So just the power of GPU And CNTK, the library using it, reduces that by 30x. And finally, once you get the features extracted, you insert the features into the table. So that sort of completes the featureization phase. Right. Now let's basically take a look at the next one, which is the training phase. Here's actually very simple. So the features that got extracted essentially are split into two parts. The first one is essentially used in combination with labeling. It's a manual step where, think about in our scenarios, the doctors are using their judgment to look at the picture of the lungs and determine whether the probability of cancer is high or not. Right? So that's the labeling phase. You basically take the label data, take the feature extraction data, train the model, and verify it using the manual labeling. And the whole process sort of goes into training the model. The classifier, right? So the classifier, again, here is an open source machine learning model from Microsoft, LightGBM, that we're using. And once it's trained using the label data and the feature extractions that we did, you insert the model back inside the database. Again, fairly straightforward. Now, the final step is the scoring one, where we actually use new images of patients, send them through the feature extraction phase, again, what we've done, and then classify them by scoring them against the LightGBM model that we trained in the previous step. All right, so sort of take a look at how simple that is. So patient ID query gets the patient ID from the information that's already stored inside the database. For this particular patient, take all the scanned images, send them to the feature extraction phase. That's the get feature step. And then finally, again, get the model out. Remember, we sort of trained the model and installed it inside the database. We're getting that out. And finally, a simple check, which is prediction based on the model that we trained and the feature set for these set of images for the patient, is the probability of cancer. Now, this essentially is the store procedure that the application called. All the magic, again, of creating the model, storing the data, storing the models, is all happening inside the database. And from the application side, we're just calling it. So what you've basically seen here, essentially, is how easy it was to basically go embed deep learning based on Python code inside SQL Server using the same extensibility model that we had built for our services. We're now getting Python in. Now let me actually show you how we are able to actually host other open source Python libraries, deep learning libraries as well. So what I have on this VM essentially is TensorFlow installed, and it's basically a very simple application that just hosts TensorFlow and does a hello world. Let's go and execute that and see how that works. Okay. Again, there you go. This is effectively TensorFlow installed on the machine, hosted inside SQL Server to basically do deep learning-based applications. Now, finally, I just basically want to close with the key points that you just saw. First thing is building enterprise-grade AI apps using deep learning and based on Python is extremely simple now. It follows the same extensibility model that we built with R. Again, since the data, the model, the intelligence is built inside SQL Server, as Joseph said, all the value around security, the trusted platform, enterprise grade, manageability, etc., you get that on all of these things that are built in. And finally, accelerating the performance. And this is truly the innovation here, where all the code, all this deep learning-based code that uses GPUs can be hosted natively inside SQL Server to produce these intelligent applications. Thank you.
Thank you, Rohan. Isn't that amazing? R, Python, deep learning with CNTK, with TensorFlow, arbitrary Python libraries and like OpenCV, all of that integrated into the industrial strength relational database management system that is SQL Server. What you've just seen is the first commercial RDBMS with support for AI. And that deserves a hand. Now, with all of the investments that we have made in making SQL Server a powerful data platform, we have customers creating revolutionary applications, such as intelligent data warehouses. For example, there's Jack Henry & Associates, an independent software vendor, who's now transforming their industry with SQL Server as a real-time data warehouse, doing operational analytics and even predictive analytics with very low total cost of ownership. SQL Server 2017 combines the best of databases and AI and analytics into one product. Everything built in. So now let's switch focus a little bit to data platforms for building intelligent software as a service in the cloud. SaaS applications are being built today with incredible data scale. Applications such as online multiplayer games, mobile ordering apps, online retail, they require very low latency writes, multi-region databases, and flexible schemas. So Azure Document DB is a cutting-edge database designed for such ultra large-scale SaaS applications. In fact, it is the first planet-scale, globally distributed NoSQL database service. It is designed as a globally distributed database system from the very ground up, allowing customers to distribute their data across any number of Azure regions worldwide. So apps can serve data from a region closest to their users for fast, uninterrupted access. It allows customers to scale throughput and storage independently across any number of regions. These are all unique features, folks. It's low latency, and it's guaranteed to have less than 10 millisecond latencies on reads and less than 15 millisecond latencies on writes for 99% of requests. And it's the only service that allows comprehensive SLAs for data loss, latency, availability, consistency, and throughput. SLAs for all of those. It is indeed a truly unique database designed for rapid development of mobile and IoT applications. It actually gives you 4 well-defined data consistency levels to choose from: eventual consistency, session consistency, bounded staleness, and strong consistency. That's more power to the app developer. It has native support for SQL, for JavaScript, and MongoDB protocols. It's schema agnostic and is capable of automatically indexing data. So you can do very, very powerful querying of your NoSQL data. And it's capable of ingesting sustained volumes of writes and automatically indexing all that data without any manual index management. And finally, it brings analytics to all that data. It has seamless integration with Spark for advanced analytics. The Spark connector that we have built for DocumentDB, it understands the physical structure of the DocumentDB store and enables computation pushdown for efficient processing. So now let's hear from a customer using all of that power.
Domino's main customer demographic consume technology on a daily basis. It's part of their life. They have very little tolerance for solutions that don't run well or don't run at all.
We have experienced an outage in the past which has taken down ordering globally. Choosing DocumentDB gave us capability to regionally distribute data and to scale the database easily. It's very easy to provision.
Because the peak periods are so valuable to our business, we really strive to maintain a 99.99% uptime. On the Azure platform, we can fail our traffic over to complete other countries. Whether you're ordering a pizza in Australia or Japan or over in Europe, you can rely on the DocumentDB performance. Even with the global scaling, we can still rely on that millisecond low latency. Serverless computing for us is really handy in moving our data around. We know at Azure Functions has infinite scale, so we can move as much data as we need.
We basically rely on data to make all our decisions. It drives our strategy, our campaigns. It's essentially providing a view to the outside world. We had a particular requirement with Europe to keep our information encrypted. SQL Always Encrypted is very important. We use that actively to ensure security of all our customer data. With Azure, it's opened a whole new ball game. We've got Azure Data Warehouse to deliver more insights to the business.
We don't have to worry about outgrowing the platform or having tools that are dated. We know that Azure is always going to be at the cutting edge of any cloud technology.
Domino's is a company that never wants to be ordinary. We want to continue to develop and deploy meaningful tech, to continue to grow and expand the business, and we're willing to put our trust into Microsoft.
Azure provides an end-to-end platform with an integrated and comprehensive set of tools and services to help you build intelligent applications. We call it Cortana Intelligence. It integrates services for information management, big data, machine learning, AI, a bot framework, and business intelligence, all together. The best way to understand what's possible with all of this power is to walk through an example of an AI application built on the cloud. So let's look at an example of a next-generation AI-powered customer service application. AI has the potential to significantly improve customer experience in service situations. Not only can customers get instant, high-quality responses to their questions and needs, but by learning from vast amounts of historical data, AI systems can anticipate problems and head off customer churn. So let's see all of this through a demo. Let me invite Daniel Dean, our Senior Data Scientist Lead, on stage to demo this intelligent customer service application. Danielle?
Great, thanks, Joseph. So I have some super exciting news to share today. I might be being selfish because the news I have to share is I bought a car. So I bought a car yesterday. Now I need to get insurance for this car. So let me actually browse to the website of my insurance agency and actually go about trying to purchase an auto policy. So here I see a live chat. So there's a bot that's available to actually speak with me to help me understand how I can buy an auto insurance policy. Now, bots support a lot of different patterns of interactions with our customers. We actually have a translator API that's working here where it can actually detect the language that I'm typing in and automatically write back in the appropriate language. Now, we can do some basic things like question and answer. So we ask, for example, where are you located? Now, the bot is going to understand the intent of what I'm saying, no matter what type of phrase that I actually use. So now I obviously came here to buy insurance, so let's go ahead and do that. Insurance. Now, this actually uses LUIS, the Language Understanding Intelligence Service, to actually understand the underlying intent. If I had said I want auto insurance, it wouldn't have actually asked me what type of insurance I want. So here, it actually asked me, I want auto, and it's now going to walk me through trying to actually authenticate if I'm an existing user or not. So in this case, I'm going to say, yes, I am an existing user. And what it's doing is it's actually connecting back to dynamic CRM to gather customer information and put that back into the framework. So here you could actually do smart authentication, things like facial recognition or voice recognition. In this case, I'm just going to do a simple personal identification number. And again, it's connecting back to that dynamic CRM to gather information about me. Now, after it authenticates me and it connects to all those systems, it's going to ask me more details about what kind of car I have. So I'm going to walk through and say I bought a Ford, for example, and I bought a Ford Fusion. It's a pretty exciting new car. And you also see that not only can you interact with the bot through typing, you actually have some nice options, some cards that display really nice little buttons here. And so it's actually going to ask me to upload a photo. I'm going to do that quick. Upload a photo here. Oops. So here I didn't pick the car. I actually picked a picture of my dog, and it says it looks like more like a dog standing on a field. I'm kind of disappointed it didn't say it was the most beautiful dog in the world, but I'll take it. So here it's really nice to be able to use the computer vision APIs. It actually detects what's in the image, making sure it's something appropriate if in this case. So let me do this right this time. So I'll get my Ford Fusion picture. And now the bot is actually going to understand that picture and actually try to build an appropriate quote for me. Now, in this case, it's not just going to use traditional risk assessment systems. It's actually going to use things like Azure machine learning models to understand my underlying propensity for churn. So really enhancing what you can do with traditional risk assessment systems. So you see in this case, it proposes a policy for me. And now I'm going to react to that policy and say whether I want to use it or not. Now, if I like this policy, it'd bring me to the payment process, maybe even use an existing method that's already there. But in this case, I'm going to say, say, no, that's way too expensive. And now the bot is going to use the Cognitive Services Text Analytics APIs to understand the sentiment of that. And actually you're going to say, oh, you know what, I can't actually deal with this as a bot. Let's bring in a human to actually help with this and help close that interaction. Now, as the human agent coming into this interaction, I need to understand what's going on, what is this customer information. Now, all of the information from that bot is going to be brought into Dynamic CRM, so you can see what the chat history is. You can see information about how long I've been a member at this insurance company, as well as getting information about the likelihood of churn with that machine learning model, as well as recommendations for what the human agent should actually consider. Maybe a discount in this case would make me less likely to churn. And so the agent actually has all of this information right at their fingertips to then go interact with that customer. Now, all of the information from these live chats are going to be hosted into CRM, but as across all of those different chats, you can actually aggregate that information and get even more insights on top of your data. You can actually do assessment in near real time to understand what trends are happening and what might be going wrong across your entire company. So for example, we can zoom in and look at some negative sentiment that's happening in Australia. And we see our word cloud says Contoso Insurance, expensive. This might indicate that our competitor is actually doing well in this market and our prices are too high. So with just this Power BI type of tool, you can actually zoom in and look at all of that information available to you. So what I've shown you here is the bot framework, how it enables you to have a really natural, personal conversation with your customers, interact with them, and then you can enhance that with machine learning and visualizations to really make the most value for your business. Thank you.
Let's now talk about the second theme, trust. It's simple. You should trust our data solutions to keep your data safe. You should trust our platforms to grow with your needs and never limit you in scale. Two key things that we promise our customers. So first, let's talk about keeping your data safe. You own your own data. With Azure, you have ownership of customer data, that's text, sound, video, or image files and software, and we guarantee that all of this data is secured by our data platforms. You are in control of your data. We conform to global standards. Azure meets a broad set of international and industry-specific compliance standards, such as ISO 27001, HIPAA, FedRAMP, SOC 1 and SOC 2, as well as country-specific standards like Australia IRAP, UK G Cloud, and Singapore MTCS. And second aspect of trust, you can trust us to grow and scale so that your cloud services have no limits on headroom. With every iteration and release of our products, we continue to improve our capabilities to ensure that we keep your data safe and that our infrastructure can grow with your needs over time. And now we are embedding advanced capabilities like machine learning directly into our cloud services to deliver intelligence to keep your data safe. For example, consider the security features in Azure SQL Database. Our ML systems behind the scenes of SQL Database today analyze and learn from over 700 terabytes of data per day to ensure we keep your applications highly efficient and safe through automatic auditing and threat detection. With active threat detection, the Azure SQL DB service can now identify anomalies in your workload and can alert you of potential attacks like SQL injections. And the service does the hard work, so you don't have to. So you can focus on business problems you're solving and creating breakthrough applications. In addition to automatic threat detection, SQL provides an alternative with SQL authentication. It simplifies password management by allowing you to connect to a number of Azure services, including Azure SQL Database, using the same identity. It allows access to rows of data based on a user's identity, role memberships, or even query execution context. That's powerful. It lets you define masking patterns on database columns to limit the exposure of sensitive data. And all of these are features that ensure that your data is the most trusted it can be when it's in a database. So let me show you how easy it is to turn on auditing and threat detection in Azure SQL Database. We are making it extremely easy for you to use the power of machine learning for automated auditing and threat detection. It's extremely easy to enable. All you have to do is go to Azure portal, simply select auditing and threat detection in the settings blade. Then turn on auditing and click Save. With 3 clicks, you're automatically using machine learning to detect anomalous database activities. In the case of any anomalous activity, you will automatically receive an email notification. The email will provide information on the suspicious security event, including the nature of anomalous activities, the database name, server name, and the event time. In addition, it will provide information on possible causes and recommended actions to investigate and mitigate the potential threat to the database. We are making it extremely easy for you to use the power of machine learning for automatic auditing and threat detection. Not only are we making our services smarter and safer for you, we are also building data services to enable you to build globally scalable applications with extremely low latency. So what we're doing is using machine learning to deliver unparalleled performance. It's a learning database that automatically analyzes queries, automatically indexes and tunes the indexes tailored to each workload so your performance constantly improves. We can use AI to auto-index your data so you don't have to. Our databases are also built to scale for the most demanding applications, leveraging the incredible global scale of Azure. For example, Azure SQL DB now allows any SaaS application to achieve unlimited global read scale with chained geo-replication. Azure SQL DB supports self-service activation in all service tiers. And you can set automatic failover policies. And you can replicate data to any Azure region, allowing you to serve read queries for these ultra-scale software as a service applications from multiple regions globally. So your applications have plenty of headroom. Let's now talk about the third theme, developer flexibility. Our customers want flexibility when it comes to the choice of the platform, programming languages, and data infrastructure so that they can get the most from their data. Customers want the flexibility to deploy anywhere, on-premises or in the cloud, the flexibility to use any type of data, even querying Hadoop systems and handling JSON data. They want to be able to run on any choice of OS, on Windows or Linux, or even in Docker containers in Linux, and use open source, such as R and Python, to program analytics and AI. And finally, any type of application, Java, Ruby-based, Python-based, should be able to efficiently use the database. And SQL Server provides all of these. It is truly a platform for data-driven intelligence. Today, we are also announcing the release of R Server 9.1, adding to that flexibility. It is a standalone analytical platform that can be deployed anywhere your data lives. It comes with SQL Server when you buy SQL Server, but it also supports Hadoop, Spark, and Teradata in addition. There are some very exciting advances for machine learning and AI in this release of R Server. It is scalable R-based machine learning, algorithms from Microsoft, made scalable and parallel. It now has a pre-trained collection of cognitive models for analyzing text and sentiment. It even supports GPU. You have GPU-powered deep learning. All of these are now available on both Windows and Linux. It's a unique enterprise analytical platform that combines the best of open source and proprietary source. We've shared a lot of exciting product capabilities today. Now, with the power of the cloud, it's never been easier for you to get started building your intelligent SaaS applications. As we have worked with our customers, we have identified the most common patterns for implementing big data and advanced analytics applications. And we have now codified these learnings into predefined reference architectures to make development simple. We call these solution templates. Cortana Intelligent Solution Templates, now available, they provide reference architectures for common ways of combining multiple services on Azure. It's built on best practice design patterns. It's based on real-world customer implementations by our engineering team. And the value is incredible. It accelerates the time to value for an intelligent application building to deploy a complex architecture. And you can do that now in minutes instead of days and weeks. It's flexible and scalable. And these solution templates, you can customize them. You can customize them to your specific needs. And it's even backed by a rich partner ecosystem. It can be deployed in your Azure subscription, where you can bring even other pieces and scale these up and down. So today, 3 new solution templates are available. And they look like this. These are a collection of services that are connected together. And the 3 things that are available today are personalization, demand forecasting, and quality assurance, with many more to come in the future. So I started out this conversation with what drives us. Solving big problems such as understanding the universe, solving cancer, and making the world a more sustainable place for all of us. These problems are now becoming tractable with our data platforms. The investments we are making in our data platform are helping take science and technology and software to a completely new level. So let's step back a bit. In 1769, James Watt invented the steam engine. It kicked off the Industrial Revolution that transformed the world in the subsequent decades. The steam engine of today is the intelligent cloud. It is kicking off the intelligence revolution, which will transform the world in the next few decades. It'll be one of the most exciting times in human history. Thank you.